@NCERT video book welcomes you. Today we are going to start Social Science textbook for grade 6, Exploring Society, India and Beyond. Today we will study Chapter 1, Locating Places on the Earth. Let's start Chapter 1, Locating Places on the Earth. The globe of the Earth stands in space, made up of water, earth, fire, and air, and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic. Aryabhat, about 500 CE. Let's understand what is the meaning of CE. For this, we will move to chapter 4. In the West, the conventional year for Jesus Christ's birth has generally been taken to be the starting point of this calendar. Years are counted forward from this point and used to be marked with AD, an abbreviation for a Latin phrase that refers to the years after Jesus' birth. However, this is now called the Common Era or CE across the world. For example, 1947, the year India gained independence, can be written as 1947 AD, sometimes AD 1947 or 1947 CE. Similarly, the years before the conventional date for the birth of Jesus was counted backward and used to be marked with BC or before Christ. They are now called before Common Era or BCE. For example, 560 BCE is an approximate year of birth of Gautam Buddha, whom we will meet in chapter 7. Can you calculate how many years ago that was? The overall summary is here. Jesus' birth is taken as reference. Before Jesus' birth, the years are written in BCE or before Common Era, and after Jesus' birth, the years are counted as CE, that is Common Era, sometimes written as AD. Note there is no 0 year or something like that. There is 1 AD or 1 CE or 1 BCE. Similarly, there is 2 BCE and 2 CE, like that. There is no 0 CE, 0 AD or 0 BCE. Let's return to chapter 1. The big questions. 1. What is a map and how do we use it? What are its main components? 2. What are coordinates? How can latitude and longitude be used to mark any location on the earth? 3. How are local time and standard time related to longitude? Imagine that You are visiting a city for the first time. How would you find the places you want to visit? You might ask a local person for help, or you might look at a map of the city. In previous grades, you learned a little about maps, and in this chapter, we will study them in more detail. Let us play a game. Examine the map of this small city, figure 1.1. Figure 1.1. A map of an imaginary small city. You can see school, railway station, hospital, market, museum, bank, Nagar Panchayat, apartment. You can see a park, a lake, and railway line here. Similarly, you can see two double-headed arrow cutting each other at 90 degree, pointing directions north, south, east, west. Imagine that you just got off a train at the railway station and you want to visit the bank marked on the map. You can see railway station here and bank here. There are many ways to go there. You can go like this, or like this, or like this. Which way would you go? Are there other possible ways? Can you locate the public garden, the school, and the museum? You can see the public garden here, museum here, and school here. If you want to proceed from the bank to the market, which way will you go? From bank to the market, the shortest path is like this. This is where a map comes in handy. A map is like a treasure guide. It shows you where things are and how to get to them. Notice the four arrows in the top right corner of the map. We will soon see how they point to some specific directions and make maps even more helpful. Let's explore. On the map in figure 1.1 given on page 8, 1. Mark the hospital. You can see hospital here. 2. What is the meaning of the blue colored areas? Blue colored areas signify water bodies. 3. Which is farther away from the railway station? The school, the Nagar Panchayat, or the public garden? You can see public garden here, Nagar Panchayat here, and school here. From railway station, the public garden is farthest. As a class activity, form groups of 3 or 4 students each. Let each group try to draw a map of your school and some of the streets or roads that lead to it, and a few neighboring buildings. At the end, compare all the maps and discuss. A map and its components. From this simple example, we understand that a map is a representation or a drawing of some area. It may be a small area, a village, a town, etc. A bigger area, say your district or state, or a very large area like India or even the whole world. In a map, you look at the surface as if you are viewing it from the top. An atlas is a book or collection of maps. As you will discover, there are several kinds of maps. Physical maps, which mainly show some natural features such as mountains, oceans and rivers. See an example in figure 5.2 in this textbook. Figure 5.2 is given in chapter 5. Let's move to chapter 5. Figure 5.2, a physical map of the Indian subcontinent with some of its rivers. You can see a physical map of Indian subcontinent. You can see Arabian Sea, Bay of Bengal, Hindu Kush Range, Himalayas, and various rivers flowing here. Political maps, which show details of countries or states, boundaries, cities, etc. For instance, a map of India with all its states, union territories, and their capitals. Thematic maps with a specific kind of information. Examples include Figure 6.3 and Figure 8.1 in this textbook. Let's move to Chapter 6 and Chapter 8 to see Figure 6.3 and 8.1. Figure 6.3, map of some of the main settlements of the Indus-Saraswati civilization. Notice the natural boundaries formed by the mountain ranges in brown color. You can see a thematic map here. Let's move to Chapter 8. Figure 8.1, a few examples of cereals and pulses from different regions of India. You can see another thematic map here. Let's move to Chapter 1. There are mainly three kinds of maps: physical maps, political maps, and thematic maps. In addition, there are three important components of maps: distance, direction, and symbols. You have already experienced the first two while navigating the map in Figure 1.1. Let us now define them more precisely. Have you ever wondered how a huge place can fit on a small piece of paper? It is all thanks to the map's scale. Let us go back to our map of a small city, Figure 1.1. Each centimeter on the map, as printed here, represents a certain distance on the ground. Let us suppose it is 500 meters. We say that the scale is 1 centimeter equal to 500 meter. Now turn to the map of India in figure 5.2 in chapter 5 of this textbook. The scale is represented in the bottom left corner by a ruler with 500 written above its length and kilometer on the side. It simply means that this ruler which measures 2.5 centimeter in the printed map, corresponds to 500 kilometers on the ground. So, the actual distance between the 2 points represented on the map depends on the scale that the map is using. Let's see figure 5.2. Figure 5.2. You can see scale here. 500 kilometer is represented by this length. It is about 2.5 centimeter. That means 2.5 centimeter on paper represent 500 kilometer on the ground. The scale is 2.5 centimeter is equal to 500 kilometer, or 1 centimeter is equal to 500 divided by 2.5 kilometer, or 200 kilometer. That means it can be also written as 1 centimeter is equal to 200 kilometer, or it can be made like this. If this is 1 centimeter, you can write 200 above and kilometer on the right. Let's move to chapter 1. Draw a simple map of a school's playground. Let us assume it is a rectangle, 40 meter in length and 30 meter in width. Draw it precisely with your ruler on a scale of 1 centimeter is equal to 10 meter. For the map of this playground, you have to draw 4 centimeter and 3 centimeter like this, and you have to write 1 centimeter is equal to 10 meter. The map of the playground will be like this. Now measure the diagonal of the rectangle. How many centimeters do you get? Using the scale, calculate the real length of the playground's diagonal in meters. The length of diagonal on the map will be 5 centimeter, and it will corresponds to 50 meter on the ground. Let us return to the 4 arrows at the top right of the small city's map. They point to 4 directions, which are north at the top and moving clockwise, east, south and west. These are called the cardinal directions. This is north, this is east, this is south and this is west. North represented by N, east represented by E, south represented by S and west represented by W. You will get east, south, west on moving clockwise from the north. These are also called cardinal points. Other than these, intermediate directions are also used, such as northeast, southeast, southwest and northwest. You can see northeast, southeast, southwest, northwest. Most maps simply have an arrow marked with letter N, which points to the north direction. In most maps, only north direction is given, like this. You can find the other direction by comparing with this one. Let's explore. Consider the map of the small city again. Identify the correct and incorrect statements in the list below. 1. The market is north of the hospital. Market is here and hospital is here. Market is in the southeast of hospital. So, the statement is wrong or incorrect. 2. The museum is the southeast of the bank. You can see the bank is here and the museum is here. So you can say museum is in the south of the bank. So the statement is wrong or incorrect. 3. The railway station is northwest of the hospital. The railway station is northwest, north here, west here. This is northwest of the hospital. This statement is correct. 4. The lake is northwest of the apartment blocks. You can see the lake here. The lake is toward the southwest of the apartment block, not the northwest. So the statement is wrong. Incorrect. Taking your school as a starting point, do you know approximately in which cardinal direction your home is located? Discuss with your teacher and your parents. Symbols are another important component of maps. Our map has several drawings of actual buildings and a few other elements. But there would not be enough space on the map of a large city or a country to draw them all. Instead, a symbol is used to represent these features. Symbols for different kinds of buildings, for instance, a railway station, a school, a post office, for roads and railway lines, and for natural elements such as a river, a pond, or a forest. In that way, numerous details can be shown in the limited space available on a map. To make maps more easily understood by a variety of users, map makers use specific symbols. Different countries use different sets of symbols. The Survey of India, a government body, has fixed a set of symbols for maps of India or parts of India. A small selection of them is shown in figure 1.2 on page 12. Figure 1.2. A selection of symbols commonly used in maps. You can see railway lines, broad gauge, meter gauge, railway station. Broad gauge, meter gauge, railway station. Roads, metalled, unmetalled. Metalled road, unmetalled road. Boundary, international, state, district. Boundary, international, state, district. River, well, tank, canal, bridge. River, well, tank, canal, bridge. Temple, church, mosque, chhatri. Temple, church, mosque, chhatri. Post office, Post and Telegraph Office, Police Station. PO, Post Office. PTO, Post and Telegraph Office. PS, Police Station. Settlement, Graveyard. Settlement, Graveyard. Trees, Grass. Trees, Grass. Let's explore. Draw a rough map of your locality or your village, including your home, school, and a few other important landmarks. So, the cardinal directions and use a few of the symbols shown in figure 1.2 on page 12 to mark some important features. Mapping the Earth. Mapping the Earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not a perfect sphere, but is slightly flattened at the poles. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try and flatten them on a table. You will see that you cannot do it without tearing them at the edges. Now consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars, and constellations in the sky, etc. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metal, plastic, or cardboard. Here we will study the globe representing the Earth's geography. Because the globe and the Earth have the same spherical shape, a globe will better represent the geography of the Earth than a flat map. Let us now explore some of its features. A. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops, all the same size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So you would give directions like meet me at 6 p.m. at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Now consider a chessboard like this. To record moves by advanced players, letters are placed alongside the main pieces from A to H. See the image, and numbers from 1 to 8 in between the two sides. You can see A, B, C, D, E, F, G, H on horizontal and 1, 2, 3, 4, 5, 6, 7, 8 written on the vertical. This simple system allows players to mark each square and record every move. Here, the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So, the pawn is said to have moved from d2 to d4. You can see d2, that is, this is d2 and d4. That means this is d4. Let's explore. Using the same terms, write down your move if you play black and respond with the same move. This black queen's pawn is at d7. and we'll move to D5, that is here. The system used in these two examples may be called a system of coordinates. Thanks to their two coordinates, the stationary shop as well as the chess square on the chessboard can be precisely determined. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. B. Latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed points at the top and bottom are the two poles. Halfway between them is the equator. Note the circle marking it. See figure 1.3. You can see North Pole here and South Pole will be here. From the middle you can see equator, that is the largest circle encircling the earth from the center to its center. Suppose this is earth, then this will be the North Pole and this one will be South Pole. And the circle that splits earth into two parts in horizontal will be the equator. Imagine that you stand on the equator and travel towards one of the two poles. If you move toward poles on either side, your distance from the equator increases. Latitude measures the distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west parallel to the equator. Such a line is called a parallel of latitude, and it draws a circle around the earth. All the lines that are parallel to the equator or all the circles that are parallel to the equator will be called parallels of latitude. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by parallels of latitude grow smaller as we move northward or southward. Figure 1.3. You can see different horizontal circles running parallel to equator like this. You can see as you move towards poles, the size of the circles decreases or the size of parallels of latitude decreases. Figure 1.3. This globe shows both parallels of latitude and meridians of longitudes. Latitude are expressed in degrees. By convention, the equator is latitude 0 or 0 degree, while the latitude of the two poles are 90 degree north and 90 degree south respectively. This is noted 90 degree north and 90 degree south. You can see it is written here 90 degree north. Similarly, the south pole will be 90 degree south. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is also called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperate. And closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so, and also why we experience different seasons in the course of a year. You can see different degrees of parallels of latitude, such as 30° north, 60° north, and 90° north. Similarly, you can see 0° for equator. Similarly, 30° south, there will be 60° south and 90° south. Not visible here. See longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well pass through Asia. The distance would be the same. These lines are called meridians of longitude. Figure 1.3. They are all half circles running from one pole to the other. Suppose this is Earth, then all the semicircles in vertical direction like this, joining the two poles, will be the meridians of longitude. You can see in figure 1.3, the vertical semicircles joining the two poles are meridians of longitude. Note the size of each meridians of longitude is same. You will also learn in science that the earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe, focused on it, and imagine that this is the sun illuminating the earth. Slowly rotating the globe eastward, we can note that for some places on earth, it is morning, while for others it is midday, evening, or night. When it is breakfast time in one country, it's lunch time in another, and in a third country, people are fast asleep. That is why, by measuring the longitude of a place, we will also be measuring the time at that place. Let us see how. To measure longitudes, we need to define a reference point called the prime meridian. Figure 1.3 on page 15. You can see in figure 1.3 prime meridian here. It is also called Greenwich meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, would become the international standard for the prime meridian. It is marked as 0° longitude. Prime meridian passes through a place called Greenwich in London. It is also called 0° longitude, joining the North and South Pole. Just as latitude is a measure of the distance from the equator, if you travel towards one of the poles, longitude is a measure of the distance from the prime meridian if you travel along the equator. Longitude 2 is measured in degrees. Westward or eastward, it increases in value from 0 degree to 180 degree with the letter W or E added. For instance, using round figures, New York's longitude is 74 degree west, while Delhi's is 77 degree east, and Tokyo's is 140 degree east. All the meridians of longitudes towards east from the prime meridian is numbered like 30 degree east, 60 degree east, 90 degree east, and so on up to 179 degree east. And just opposite to prime meridian, there will be 180 degree meridian of longitude. Note that neither east nor west is written after 180 degree meridian of longitude. Similarly, towards west, 30 degree west, 60 degree west, 90 degree west, similarly 179 degree west. After that, you will again get 180 degree meridian of longitude. There will be 1 degree west, 1 degree east, 2 degree west, 2 degree east, and so on. Don't miss out. As you see on the globe of meridians of longitude 180 degree west and 180 degree east are the same longitude. So this longitude is noted 180 degree, omitting the letter W or E. Latitude and longitude together are the two coordinates of a place. With them, you can now able to locate any place on earth. You can now understand a statement such as Delhi lies at 29 degree north latitude and 77 degree east longitude. These values are rounded off, not exact. Figure 1.3 on page 15 shows the parallels of latitude and the meridians of longitude together on the globe as blue lines. All these lines together constitute a grid for the globe. They are also called grid lines. Let's explore. If the globe or atlas in your class has well marked latitudes and longitudes, try to note down approximate values for the latitude and longitude of 1. Mumbai, 2. Kolkata, 3. Singapore, 4. Paris. Figure 1.4. This sketch shows how the prime meridian divides the earth into the western and eastern hemispheres, while the equator divides it into northern and southern hemispheres. You can see Greenwich meridian or prime meridian or 0 degree meridian. It divides the earth in western hemisphere and eastern hemisphere. Similarly, equator or 0 degree latitude divides the earth into northern hemisphere and southern hemisphere. Don't miss out. The Greenwich meridian is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own. Figure 1.5. It was called Madhya Rekha or middle line and passed through the city of Ujjaini, today Ujjain, which was a reputed center for astronomy over many centuries. Virhamihir, a famous astronomer, lived and worked there some 1500 years ago. Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or prime meridian. The Ujjaini meridian became a reference for calculations in all Indian astronomical texts. You can see Ujjaini meridian or prime meridian in the ancient time 75.8 degree east. Figure 1.5. The Ujjaini prime meridian used in ancient Indian astronomy. Cities marked with a circle are mentioned in astronomical texts as being on this meridian. The modern name is given after the oblique bar. Ancient city shown using circle, modern city shown using square. Ancient city कुरुक्षेत्र, रोहितक और रोहतक, मालवन गारा और नगर, उज्जैनी और उज्जैन, माहिष्मति और माहेश्वर, कुमारी और कन्याकुमारी. मॉडर्न सिटी दिल्ली, मुंबई, कोलकाता, बेंगलुरु, चेन्नई, etc. The map shows a few ancient cities close to the Ujjaini meridian. Some are very close to it, while others are a little away. That is because measuring longitude required accurate timekeeping, which was not as precise then as it is today. Figure 1.6. This map, published by the Survey of India, shows the country's outline along with a few parallels of latitude and meridians of longitude. India's latitudes extend approximately from 8 degree north to 37 degree north and latitudes approximately from 68 degree east to 97 degree east. The two colors have been added. You can see a map of India is given here and the extent of India is 8 degree north, parallel of latitude to 37 degree north, parallel of latitude. Similarly, 68 degree east, meridian of longitude to 97 degree east, meridian of longitude. You can see some latitude and longitude measures are written at the borders. Understanding time zones. Let's make the globe rotate again from west to east. That is how our planet spins around its axis, making a full turn every 24 hours. A full turn is 360 degree. So this means 15 degree per hour because 15 into 24 is equal to 360. You can understand this. 360 degree covered in 24 hour, that means 15 degree covered in each hour. Let us now mark the meridians of longitude every 15 degree. Moving eastward From the prime meridian, we get 0 degree, 15 degree east, 30 degree east, 45 degree east, and so on every 15 degree up to 180 degree. It is the same as adding 1 hour of local time with each meridian. If it is 12 pm or noon at Greenwich, it is 1 pm local time at 15 degree east, 2 pm at 30 degree east, and so on. But going westward, it is the other way round. 11 am local time at 15 degree west, 10 am at 30 degree west, etc. You can see this width is of 15 degree, signifies 1 hour. If it is 12 am at 0 degree meridian or prime meridian, then it will be 11 am at 15 degree west, 1 pm at 15 degree east. Similarly, at 30 degree west, there will be 10 am, and at 30 degree east, there will be 2 pm. Similarly, 45 degree west, 9 am, 45 degree east, 3 pm. Figure 1.7. This graph shows longitudes at the bottom and the local time at the top. With reference to the prime meridian at 0 degree, each color is a zone centered on a meridian. This is a zone of 15 degree. This is another zone of 15 degree. Zone of 15 degree colored using different colors. Let's explore. Two friends, one sitting in Porbandar, Gujarat, and the other in Tinsukia, Assam, are speaking on the phone late afternoon. The latter remarks that the sun has set in Assam and it's now dark. The former is surprised and says, "But it is still full daylight here. Explain why." And as a class activity, calculate the difference in local time between those two cities. Hint: for now, consider the difference in longitude between Porbandar and Tinsukia to be 30 degree. Later, you can find out the precise value. You can see the longitudinal extent of India is around 29 degree, or in round figure you can say 30 degree. So there will be difference of 2 hours in time between a place at 97 degree east and a place around 68 degree east. The same method can be used to calculate the local time of a place on the earth, but it would not be convenient for a country to use many local times. That is why most countries adopt a standard time based on a meridian passing through them. Indian Standard Time, or IST, is 5 hours 30 minutes, also noted 5.5 hours, ahead of the local time at Greenwich, called Greenwich Mean Time or GMT. Please note that for adopting a standard time, a meridian of longitude is selected and time corresponds to that meridian is taken as standard time. For India, the standard time meridian is 82.5 degree east. It gives a difference of 5.5 hours or 5.5 hours from Greenwich Mean Time. Actually, India is towards east, so you have to add 5.5 hours to Greenwich Mean Time to get Indian Standard Time or IST. Let's explore. Return to the two friends sitting in Gujarat and Assam. Use this example to explain the difference between local time and standard time. All these standard times are organized in time zones, which broadly follow the zones of 15° in the graph, figure 1.7. But let us consider the world map below, figure 1.8. We can see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time and therefore tend to follow international borders. You can see different time zones here. Figure 1.8, a world map of the time zones showing the standard times with respect to GMT or Greenwich Mean Time for a few countries. Note that international borders are approximate, not exact. You can see different time zones here using different colors. The numbers written inside some countries are numbers of hours to be added to GMT to get their standard times if they have positive sign or subtracted from GMT if they have a negative sign. Countries to the east of prime meridian, you can see positive numbers are written. That means to get their standard time, you have to add these numbers to the GMT or Greenwich Mean Time. Similarly, to get the standard time of the countries towards west of prime meridian, you have to subtract the numbers written on those countries from GMT. Don't miss out. From the above explanation, it may seem as if every country has one standard time. That is not always the case. Some countries like Russia, Canada, or the USA are too large to have a single time zone. The USA has 6 time zones and Russia has 11, which means that traveling across Russia from east to west, you will need to readjust your watch 10 times to align with the local time. You can see 11 time zones in Russia and 6 time zones in USA. Similarly, the globe in figure 1.9 centered on India shows standard times with respect to GMT for a few countries. You can see plus 5.5 written here for India, plus 8 for China, and you can see different time zones for Australia. Figure 1.9, a few time zones with respect to GMT in Africa and Eurasia. Finally, while the prime meridian was fixed at Greenwich, the opposite line at approximately 180° longitude is called the international date line. You can see international date line here. It is zigzag so that it doesn't crosses a country or pass over a country. As you can see on the map, the plus 12 and the minus 12 time zones touch each other at this line. If you cross it by ship or plane, you need to change the date of your watch. If you cross it traveling eastward, you subtract a day, say from Monday to Sunday. If you cross it traveling westward, you add a day from Sunday to Monday. We said that the international date line is approximately at 180-degree longitude, as it deviates in places to avoid dividing some countries into two different days. Before we move on, maps are a very useful tool to represent an area of the earth, whether small or large. The main components of maps are distance, direction, and symbols. Every place on the earth has a location which can be precisely defined with the help of a grid of latitudes and longitudes. Imaginary lines running from east to west parallel to equator and north to south from pole to pole respectively. Longitude also marks the time and defines the time zones. The international dateline is located approximately at 180 degrees longitude opposite the prime meridian. Crossing the international dateline changes the date by 1 day. Questions, activities and projects. 1. Returning to page 10 and to figure 5.2 in chapter 5 of this textbook, taking the scale to be 2.5 centimeter is equal to 500 kilometer. Calculate the real distance from the estuary of the Narmada river to the estuary of the Ganga river. Hint: round off your measurement on the map to an easy number. Estuary, the place where a river meets the sea. 2. Why is it 5:30 p.m. in India when it is 12 p.m. or noon in London? 3. Why do we need symbols and colors in the map? 4. Find out what you have in the 8 directions from your home or school. 5. What is the difference between local time and standard time? Discuss it in groups, with each group writing an answer in 100 to 150 words. Compare the answers. 6. Delhi's and Bengaluru's latitudes are 29° north and 13° north. Their longitudes are almost the same, 77° east. How much will be the difference in local time between the two cities? 7. Mark the following statements as true or false. Explain your answers with a sentence or two. All parallels of latitude have the same length. The length of a meridian of longitude is half of that of the equator. The South Pole has a latitude of 90 degrees south. In Assam, the local time and the IST are identical. Lines separating the time zones are identical with meridians of longitude. The equator is also a parallel of latitude. Solve the crossword below. Locating places on Earth. Hints are given here: across, down. For more videos, you can subscribe at the rate NCERT video book. Thank you.